Hi, in this session, we would be considering application of weighted averages in mixtures and solution. For you to do this session, it is necessary that you have done the session on weighted average and on allegations thoroughly. If you have done that, there's very little that you are going to learn new over here. The only thing that we need to understand is when we have mixtures of milk and water, what essentially does average A1 and A2 refer to, and more importantly, what do the weights W1 and W2 refer to. So we need to be very flexible, very fast in moving between terms that define how much milk, how much water is there in a solution. There are 5 ways in which this information can be provided. So let's take a solution. A vessel has milk and water. The amount of milk is 14 liters. So I'm giving you the quantity directly because it's the first question. It's pretty easy. The amount of water in it is 11 liters. So obviously the total volume of the solution is going to be 25 liters. Now, how much milk, how much water can be expressed in 5 different ways. The first is proportion of milk. What is the proportion of milk in this vessel? Obviously, by proportion of milk, we refer to the milk quantity as a fraction or as a part of the total volume. So in this our question out over here, the proportion milk is going to be 14 out of a total of 25. Now the same proportion of milk, in short we will be calling it milk proportion, yeah, so that we build up some speed. The percentage of milk, the same information can be expressed in a percentage. Percentage of milk is nothing but the proportion of milk multiplied by 100 to change the value to a percentage. So in our question here, it's going to be 14 liters out of 25. To express it as a percentage, we'll multiply by 100 and 4s are, this will be 56% will be the milk. Hope that's clear. If we could do this calculation on milk, we can even do it on water. So proportion of water. Proportion is going to be a ratio. What will be the ratio? The water quantity divided by the total volume of the solution, right? And water we have is 11 liters, total is 25. So the proportion of water is 11:25, as simple. The percentage, the same proportion, I need to express it as a percentage. So I'll just multiply it with 100. That will become 44%. Needless to say, since the solution has only 2 components, milk and water, the percentages have to add up to 100. So if I knew this is 56%, water has to be 100 minus 56, that is 44%. Similarly, the proportions also have to add up to 1, the complete solution. What fraction is milk? 14 by 25. What fraction is water? 11 by 25. What fraction is the two together? 14 by 25 plus 11 by 25, which will be 1. That is a full mixture as such, right? What is the fifth way of representing the same information of how much water and milk? That is nothing but the ratio of milk and water. So we will simply, in shorthand, we will just say this is ratio of milk and water. So here the ratio is going to be nothing but 14:11. So I've written all the 5 different ways of expressing. If I know the volumes, obviously all 5 I can calculate. So let's go ahead. Usually we would not be having the individual volumes. If any one of them is given, we should be able to move to any of them very fast. So I'm erasing all the values that I've calculated. In the most simplest question, the percentage of milk it will start with, right? And it will be, I'm talking of very simple questions, right? The value will be a very comfortable thing value. So let's say 75%, this is given to me. Milk is 75%. If milk is 75%, obviously what will water be? The total have to add up to 100%, so water is going to be 25%, right? Now, how do I write a proportion out over that? If the total was 100 liters, then milk is going to be 75 liters. Or else if you convert 75 into a fraction, it is nothing but 3/4. You could add the th for more better understanding, right? 75% of the solution, 3/4 of the solution is milk. And if milk is 3/4, what does water have to be? Water has to be 1/4. The rest of it, what do we do? 1 minus 3/4, or going the long way, if the total is 100 liters, water is going to be 25, or rather milk is given as 75, so water has to be 25, which is nothing but 1/4, right? And what will be the ratio of milk and water? Now that you know milk and water, let me add a total out over here. Had the total been 100, milk is 75, water would have been 25, so the ratio of this is nothing but 3:1. Knowing this 3/4 and 1/4, we could have taken the ratio of 3/4 and 1/4, the 4 cancels, I would have got 3:1. Right? So this is where a simple question would start off with. But more often than not, the most common data that is given to us in these questions is the ratio of milk and water. Right? So the question will start with, usually, most often the question will start with the ratio of milk and water, let's say, is 5:3. It's given to me. So you could imagine 5 liters. If milk was 5 liters, water would have been 3 liters, the total would have been 8 liters. This is all in ratios itself, right? The proportion is very easy. What is the milk? Milk is 5 out of a total of 8. What is water? Water is the balance, 3 out of a total of 8. And if I want to convert it to percentage, all that I need to do is 5/8, I need to convert to percentage. If you're good with your percentage sessions, you don't even need to write this into 100, right? 5/8 is nothing but 62.5. You should know this verbally very fast, right? And water is what? Water is 3/8. Write it as a percentage into 100, which we have already learned without getting the 100 into picture as 37.5. So starting with the ratio which was given, I have found proportion of milk, I found percentage of milk, and so also with water, right? So this should be straight. Occasionally what is going to happen is the values may not be so comfortable. So we would have, let's say the proportion is 5:4, or shall we say 6:5. So the total is going to be 11 now, 6 plus 5, 11. The proportion of milk is going to be 6 out of 11. When I convert this to a percentage, 6 out of 11, when I multiply by the 100, again, you would have to do this calculation if you're not fast with fraction percentage equivalence. However, I guess you would have done the lecture on fraction percentage equivalence. Denominator 11 means numerator will be a multiple of 9, a recurring number. 9 6 are 54. So the answer is 54.545454 percentage. It's a recurring number, right? Water was 5 out of a total of 11 in percentage. 5/11 into 100. So 9 5s are 45.454545. And if you add the two recurring numbers, you will get 99.999999 recurring, which is nothing but 100%, right? So these numbers are not very user friendly, right? They will lead to difficulty in calculation. So what I am saying is, this percentage of milk, percentage of water is nothing but this number converted to a percentage. Right? So if this number is a very easily understood percentage, then we'll convert it right over here itself. In this case, it is not so easily. So rather than using 54.5454, we will, rather than using that, we'll use 6/11 itself. Right? If it is an easy number, we can use a percentage out of it. So what you study from the last few minutes is just that you should be very swift moving between any one data to the other data. So in a lot of questions, the last question is going to be, or the last line is going to be, what is the ratio of milk and water? And in our calculations, we are going to usually work on proportion of milk. So let's say the answer turns out to be the proportion of milk is, now let me take a little nasty number. The percentage of milk is, let's say, 11 out of a total of 70. So all that you need to do to come to our answer is, assume the denominator 17 as the total. So milk is going to be 11. So what is water going to be? Obviously 17 minus 11. And these are in ratios. I do not know the actual quantity, so the ratio is going to be 11:6. Hope you get that. You need not write 17 minus 11, 17 total, 11. The rest of it is 6. So you should be able to come back to this, right? Having seen this basic stuff, let's go to how an actual question looks like. So the easy question reads as 20 liters of a solution having milk and water, with milk being 80%, is mixed with 30 liters of another solution of milk and water having 60% milk. Find the percentage of milk in the resultant, find percentage of water in the resultant, find the ratio of milk and water in the resultant solution. The question could be any of these, right? So, it's a pretty easy one. Those such easy ones are there in exams like campus recruitment tests and so on. So, it would be worthwhile to check it. So, we are given that the first one, so what we'll do is, I've done solution 1, a column for solution 1. It has milk and it has water, and we know that milk plus water has to be the total. It is given to me that the first one has 20 liters. The first solution is 20 liters. So this all is about liters. How much milk does it have? It has 80%. 80% of what? 80% of 20 liters. That is, it is going to have 16 liters of milk. If I know total is 20 and milk is 16, I obviously know water is 4 liters, right, by the subtraction. However, we could even say if milk is 80%, water has to be 20%, 20% of the total volume, which is obviously 4 liters. Can I do the same thing for the solution 2? Solution 2, it is given to me has 30 liters. Now, milk that it has is 60%. 60% of 30 liters, which will be nothing but 18 liters. Out of 30, 18 liters, so we could find water by the subtraction 12, or the other way 40% will be water. Why I am doing this is, I am telling you, there is a lot of redundancy in this table, right? You get this. Now the two solutions are mixed. Solution 1 is mixed with solution 2 to result in the resultant solution, right? So when we add, I could simply say all of this is mixed together. Milk will get added to the milk to result when 16 plus this, that is 34 liters. 4 liters water from the first vessel, 12 liters water from the second vessel. The total will be 16 liters. I could either add milk plus total, which turns out to be 50, or I could also say volume of the first solution plus volume of the second solution is volume of the resultant. So we have everything out over here. The question is asking us, let's say, the percentage of milk. So if the question is asking us milk percentage I know is nothing but milk to the total into 100 to write it as a percentage, which I could do out from this table as nothing but 34 by 50 into 100, which is nothing but 68%. Question is water percentage. Again, I know water percentage out over here. Water percentage is nothing but the amount of water. How much water does resultant have? 6 amount of water to the total into 100 to change it to percentage. So water is 16 out of a total of 50 to change it to percentage. So that is going to be twice 32. Did I have to do all of this? Not really. If milk is 68%, obviously water is going to be 100 minus 68, that is 32%. The question could also be asked, what is the ratio of the milk to water, right? So milk to water, that is 34%, that's 34 liters milk, that is 16 liters water out over here, and so when I reduce it, it will get cancelled by a 2, that will be 17:8. Could I find this value out over here also? Yes, 68% is nothing but, or 50, 34, so the balance 17 has to be, 16. 50 minus 34, 16 has to be water. Right? Hope you get this. Now this is a pretty simple one. We have found out each of these boxes because all this data was given to me. Now, can I structure this in a known format that I have already done earlier? Yes, that is the weighted average format. So we'll look at how the same thing can be structured in the weighted average. Great. So I've erased the calculation that we have done here. Here I've kept this for a reference out over here. If I am finding percentage of milk, I am looking at the first line. How is it that I have arrived at the 16? What I have done is, I am finding milk to total. Milk quantity is nothing but 80% of 20 liters, right? And from the second one, I know 60% of 30 liters is milk. Now, this refers to quantity of milk from first, quantity of milk from second. On adding, this will get added up. That is how we get 16 plus 18 is 34. Now, the total volume is going to be nothing but 20 plus 30. Now, this structure, this format, does it remind you of weighted average? We have A1 into weight 1 plus A2 into weight 2. Do we have the sum of the weights here? So, I could also consider this mixture to be an application of weighted average. It's identical to what we did. It's just in a predefined structure that we are doing it out over here. There's nothing different out there. And on calculating this, this is 16, 16 plus 18, that is 34, 34 by 50. I've got the proportion of milk. And if I've got proportion of milk, converting it to a percentage is just multiplying by 100. I could have also done it on water. I could have done the same calculation on water. So 20% of 20 liters, 20% of 20 liters. Water from the other one is just 40%, 40% of 30 liters. Now I am working on water. This will give me the total water quantity, right? Divided by the total quantity will be 20 plus 30. So I see this also resembles a weighted average format, right? So what we have learned here is in mixtures, your A1 or your A2, the averages A1, A2 could refer to the percentage of milk, or they could also refer to the percentage of water. Whatever we choose, just be consistent. If you have started with milk, you can't change to water from the second solution. Milk from the first will be added to milk from the second. Can be added, right? Or if you have started with water, continue with water, right? And the weights, more importantly, what do the weights refer to here? Weights refer to the volume of the solutions. Point here, students, if you are working in milk, doesn't mean that the volumes are that of milk. These volumes are of the total solution. Even if you are working with water, the weights refer to volume of the total solution. So irrespective of whether you are working in milk or water, weights will refer to volumes of the total solution. Yeah, keep that in mind out over there, right? And you can work on anything. The question also required us to find milk is to water, the ratio. Then is it necessary that I find milk separately, that is 80% of 20 plus 60% of 30 divided by water is 20% of 20 plus 40% of 30? You could do this, but what I want to write here is there are three of these: milk to total, water to total, milk to water. Do we really need all the three rows? If we have any two row, can we find the third row? For example, if I did not know this, will it be 16 plus 4 is 20? Will it be 18 plus 12 is 30? So, if I did not know this row, can I do the first and the third? That is what we have done out in milk to total. What have we done in the second? Second row divided by the third row. And what have we done out over here? First row divided by the third row. So, we do not have to do all three of them. This being the first question, I am just telling you that for mixtures and solution, you really don't need any theory. You're just doing milk quantity plus milk quantity, water quantity plus water quantity, total plus total. That's about it, right? Do any one of them, and we have learned if this is 34 is to 50, the total is 50, milk is 34, so the balance 16 has to be water. And if I take the ratio, this ratio has to be 34 is to 16. There's no other way. Right? If you want to convert them to percentages, just multiply by 100, right? So I think you should appreciate that while we are sticking to a format out over here, because we know it is nothing but your basic calculations here. Why is sticking to a format beneficial is, if some of these boxes are not known, introducing a variable in this box tends to get a little difficult, which is what the next question tells, right? So the next question we will see, if we start writing this, there's too much of a messy stuff here, but if we write just the one of these format, it will become a very easy one. The question reads as, I'm just making a small change to it, how many liters of a solution of milk and water having 80% milk needs to be mixed with 30 liters of solution of milk and water having 60% milk to result in a solution having 75% milk. So I've kept most of the values same. The only change is now I know the resultant is 75%, but the 20 liters I've erased that, right? How many liters? The question is how many liters, right? So, what is the issue here is the first solution, I do not know how many. I know that it is 80%, but 80% of what I do not know, right? The second solution is known completely. The second solution is 30 liters, it's the same thing. So, 60% of 30 liters, which was 18 we knew. And I am not working on water now because you have seen that I can easily deduce this information whenever I want. But the problem is, since I do not know how much it is, if I try to work out over here, I'll have to use a x liter. So this is going to be 80% of x, which has a value I do not know. And what happens is the total now is going to be 30 plus x liters. Right? So x is not known. But I know that this is nothing but 75% milk is 75% of 30 plus x. Right? So some equation is formed out over here which is not very visible, or if you can notice this cell plus 18 is going to be this, and that equation is that. But if I write the same in the format that we are accustomed to, so A1, what is the percentage of milk out over here? That is nothing but 80%. 80% of what volume? I do not know the volume, so I write an X. Plus, what do we have? 60%. 60% of what volume? Of 30. I know this is the amount of milk from first, amount of milk from second, divided by the sum of weights. So x plus 30. This will refer to the total volume. And it is given to me that this is 75%. Right? Hope you can see this, right? Now, writing this seems very easy. Even if I take this x plus 30 to the other side, what I want you to notice here is 80% of x plus 60%, I'll write it this way itself rather than 18, is nothing but 75% of x plus 30 or 30 plus x. This is exactly the equation that we are finding here. 80% of x plus 60% of 30 is equal to 75%. So, we are not doing a rocket science out over here. Don't get overawed by what is this weighted average. It is nothing but something coming from the first plus something coming from the second is equal to the resultant average into the total weight, right? So we have this question and now we can easily solve it. So 80% of x, there's a percentage everywhere, so I'm dropping that percentage out over there. So 80x plus this will be 1800 is equal to 75x plus 75 into 3 is 225 and a 0. So that will be leaving me a 5x when this goes 18. So that is going to be 450, which will result in x being equal to 90. If there's no error, that should be correct, right? So we can solve it this way. Now the advantage, if you're still worried, why do I have to stick to this? Why not just stick with this? The advantage of using something already known is, did we have an alternative to weighted average? Is there another way the weighted average can be done? Specifically when the resultant average is known to me, 75%? Yes, that is allegation. So could I solve this question easily by allegation? Yes. One of them has 80% milk average, the other one has 60%, and I know that the resultant has 75%. So could I just do 80 minus 75, which is nothing but a 5, I write it to the other side. 75 minus 15 is nothing but 60 is nothing but 15, and this is going to be the ratio of weights. Weight refer to volume, so the ratio of weights is nothing but 3 is to 1. And do I know that the second volume, that one volume corresponded to 30 liters, and if one volume corresponded to 30 liters, how much will 3 parts correspond to? Obviously, it will be 90 liters. So I can get my answer directly, right? So this is the advantage if I know that whatever we are doing here is same as the weighted average format. So when to use weighted average format, when to use allegation has been learnt in the session on allegation, right? So you should be ready and prepared with that and come here. From here onwards, I am not going to write this table, but whenever you have a doubt, what are you doing, you can refer back and write the table, create the table and see that this is identical to what you are doing summation of rows here. So this was the session on absolute basics of application of weighted average in mixtures and solution. In the sessions following this, we will be just taking up questions where the data increasingly gets tougher and tougher. So instead of percentage, a ratio of milk and water may be given, and there may be 3 solutions or so on. So let's just solve a few more difficult questions.